Assalamu alaikum. In this lecture, we are going to talk about the differential protection scheme. Let's start with the help of an example. Suppose we have an equipment which can be a bus bar or transformer or motor generator. So we can use any of these equipment in the differential protection scheme. And the selection of this equipment is made based on the points where we can measure the current. For example, if we have a bus bar or transformer, motor or a generator, we can easily use CTs on both ends of these equipments. And by using these CTs, we can easily compare the currents on the input side as well as on the output side of that particular equipment. So this is the equipment that is under protection, and we have two CTs, one after the equipment and one before the equipment, that is actually defining the zone for this protection scheme. And there are two currents that are being measured. The first one is this ILN, which is being measured by the CT before the equipment, and the other one is ILN again measured by the CT that is at the receiving end of the equipment, or the one that is connected to the load. Then after receiving this current, we have a relay that is attached in this orientation, and the differential current from both the CTs is passing through this particular relay, and this relay is the simple overcurrent relay. So whenever the current I1 minus I2 that is passing through this relay and is known as spill current is greater than the plug setting of this overcurrent relay, then the relay will operate, otherwise it will not operate. There is one more thing that has to be considered while analyzing this sort of a differential protection scheme is the dot convention. We know that in the dot convention, if one current is entering the dot, then in the secondary of the CT, the current will be leaving the dot. So in this CT, the current is entering the dot, and after dividing this current by the turn ratio, we are getting the current IL by N in the secondary of the CT. Similarly, in the other CT, that is on the load side of the equipment, we have current that is leaving the dot. So the current will be entering this dot. So by this dot convention, we know that the current that is flowing in this loop will be in this direction, because the current in this part of the CT will be flowing in the downward direction, and in this part of the circuit it will be flowing in the upward direction. And if in this loop the current is IL by N, so the current is same throughout the loop, then there will be no current that is passing through the relay, and the current through the relay is known as spill current. So if the spill current through the relay is 0, then the relay will not operate. So this is known as a differential protection scheme. So let's take the first example in which we don't have any fault in the system and we only have attached a load with the equipment that is placed here. It can be transformer or a bus bar or generator or motor, whatever it is. So we have a load that is connected to this particular equipment, and the load current is flowing through the system. So if the load current is flowing through the system, then the CT will have the same current being flowed through them. So if the same current is flowing through them, then whatever current is flowing through this CT, that is for example IL, the same current will be flowing through this CT. And the currents in the secondary of the CTs will be IL by N and IL by N. So if the same current is flowing in this branch and the same current is flowing in this branch, it means that there is no current that is flowing through this portion of the circuit, so the relay will not have any current flowing through it. So in case of load, we don't have any spill current in the system, so the relay will not operate, because the spill current should be greater than the plug setting of the overcurrent relay, which is not happening in this case, so the relay will not operate. Let's take another example in which, for example, we have an external fault. And by external fault, we mean that the fault is not occurring within the zone of this differential protection scheme. So the zone is starting from this CT till this CT, and the fault is occurring outside the zone of the relay or differential protection scheme. So if it is outside the zone of the protection scheme, then this protection scheme should not operate and the spill current should remain 0. Right? So if there is a fault at this point and IF is flowing through this short circuit, then the current that is flowing through this CT as well as this CT will remain the same. That is actually the summation of IL and IF. So if the current is same in both the CTs, then in the circuit that is attached to the CT, the current will remain same. Yes, it is a fault current, it is more than the load current, but still it is not inside the zone of this equipment or the zone of protection scheme that is applied for this. So it should not operate, and it is evident from the figure as well, because the current that is flowing through this CT as well as this CT is same. Yes, it is the fault current, but it is same. The relay will not have any current flowing through it. So this is the external fault. Now suppose we have an internal fault. There is a fault that is occurred in the equipment for which we are providing the protection, and in this case we have the current I1 that is flowing through the first CT. This is CT number 1 and this is your CT number 2. So from this CT1 we have current I1 flowing through it, and that is actually the combination of I2, which is the load current, and the fault current, the internal fault current. So there are two currents, one is the internal fault current and the other one is the load current. So this I1 is actually the summation of I2 and the internal fault current, and this I1 is flowing through CT1. But in case of CT2 we only have I2 current because the fault current is grounded at the equipment. So I2 is only flowing through C2, and this I2 is smaller than I1 because the fault current is actually at this point, so the fault current is not added into I2. So therefore the current that is flowing through CT1 is actually IY by N. In the secondary of the CT1 the current is IY by N, which is I2 plus IF over N, and at this point the current is I2 plus IF over N. And we know that as the current leaving this dot is I2, so the current that should be entering this dot is I2 by N. This is the secondary of the CT, so we have to divide I2 by the turn ratio of the CT2. So the current that should be entering this dot is I2 by N. That should be I2 by N. So if the current that is approaching this node is I2 plus IF over N, and the one that is leaving this node should be I2 by N, then the current that will be flowing through the relay is IF by N, that is the fault current. So in case of internal faults we have a current IF by N that is actually flowing through the relay, and that is always greater than the plug setting. So the spill current in this case will be the fault current. So this is a simple example of internal fault. Now that is the case when we have only one generator or single fed system, but what if we have a doubly fed system that has a generator at both ends of the equipment? So starting from one side of the equipment, the current I1 is entering this dot, so the current I1 by N should be leaving this dot, that is the secondary of the CT, and at this point we have IY by N current entering this particular node. Similarly, the I2 current is actually flowing into the dot related to CT2, CT2, this is your CT2, this is CT1. So the current that should be leaving the dot is I2 by N, because we have to divide this I2 by the turn ratio of CT. So I2 by N should be coming to this node, and the summation of these two current will be flowing through the relay, that is actually the fault current, and that will be greater than the plug setting of the relay, which is simple instantaneous overcurrent relay. So if we have a fault in the system or in the equipment that which we are providing the protection, the current will be fed from both sides. One is from generator number 1, the other one is from the generator number 2, and that fault current is replicated in the differential protection scheme as the fault current that is flowing through the relay is summation of both the currents, one from the generator number 1 and the other one from the generator number 2, and that value will always be greater than the plug setting of the overcurrent relay.